Hey guys, welcome again. So let's quickly discuss about ingress. Now we discussed in the previous lectures how Kubernetes used the service abstract as a means to proxy traffic to backing pod distributed throughout our cluster. While this is helpful in both scaling and pod recovery, there are more advanced routing scenarios that are not addressed by this design. Now, to that end, Kubernetes has added an ingress resource which allows for custom proxying and load balancing to a back server. Think of an extra layer or hop in the routing path before traffic hits our service. Just as an application has a service and a backing pod, the ingress resource needs both an ingress entry point and an ingress controller that perform the custom logic. The entry point defines the routes and the controller actually handles the routing. Now, for our example, we will use the default GCE backend. I just wanted to point out to one of the facts is, there is some limitation to be aware of when using the ingress API. And, we can have more details there, in the GitHub. I mean, you can refer GitHub wherein you can just type in beta limitations and you'll get more details. I think you should be aware of the same. And that's why, I was just recalling that. Now, as we have discussed earlier, we saw that GC cluster comes with a default back which provides layer 7 load balancing capability. We can see this controller running if we look at the Cubase system namespace. As you can see on the screen, this particular command. Now we should see an RC listed with the 17 default backend v1.0 name as shown here, as you can see here. Now this provides the ingress controller piece that actually routes the traffic defined in our ingress entry points. Let's create some resources for an ingress. Now first we will create a few new replication controller with with our image. This is a remix of the original we'll say that was displayed in a browser. The following listing shows the YAML. Now notice the three dashes that let us combine several resources into one YAML file. Now as you can see, the code here, and just relate to what I just covered. Okay. So first one is whale-rcs YAML, and now quickly I will move to the second code which I was referring to. First and second, yeah. Notice that we are creating pods with the same container but different startup parameters. Take note of the parameter for later. We will create service endpoint for each of these RCs. Now, as you can see on the screen, we have created service. Yeah. So we have endpoints for each of these RCs. Okay. So let me quickly move to the next one. Yeah. So we have created service endpoints. Now again create these with kubectl1 create -f command as follows. As you can see, here. We should see messages about the RCs and service successful creation. So next we need to define the ingress entry points. So for that we will use, let me quickly move to the next screen. Now we need to define, next we need to define the ingress entry points, we will use a.whale.hey and b.whale.hey as our demo entry points, and these are as you can see on the screen right now. Now again use kubectl1 create -f to create the ingress as you can see on the screen. Once this is successful created, we will need to wait a few moments for GC to give the ingress a static IP address. And again use the following command to watch the ingress resource. So this is the command I am mentioning, and watch the resources. You will get the details of the resources here. Since this is not a registered domain name, we will need to specify the resolution in the curl command, like this. Okay, so I'm taking a step away. Now the display, this should display the following, as you can see on the screen right now. Now we can also try the second URL and we will get our second RC as you can see here. Yes. Now we notice that the images are almost the same, except that the words from each whale reflect the startup parameter from each RC we started earlier. Thus, our two ingress points are directing traffic to different backends. Now, one disclaimer and the point to note there is, in this example, we use the default GC backend for an ingress controller. Kubernetes allows us to build our own ngINS, actually has a few versions available as well. Okay, so that's it, for ingress. I'm quickly moving and to the next title, and which is let's talk about migrations, multi-cluster and more. Now, as you have seen, whatever we discussed right from the beginning, Kubernetes offers a high level of flexibility and customization to create a service abstraction around your containers running in the cluster. However, there may be times where you want to point to something outside your cluster. An example of this would be working with legacy system or even application running on another cluster. In the case of the former, this is perfectly good strategy in order to migrate to Kubernetes and containers in general. We can begin to manage the service endpoints in the Kubernetes while stitching the stack together using the K8s orchestration concept. Additionally, we can even start bringing over pieces of the stack as the front end, one at a time, as the organization refactor application for microservices and or containerization. Now, to allow access to non-pod based application, the service construct allows you to use endpoints that are outside the cluster. Kubernetes is actually creating an endpoint resource every time you create a service that uses selector. The endpoint object keeps track of the pod IPs in the load balancing pool. Now you can see this by running a get endpoints command, as using this command. You should see something similar to this. Okay, you will note an entry for all the service we currently have running on our cluster. For most services, the endpoint are just the IP of each pod running in an RC. Now, as I mentioned, Kubernetes does not automatically based on the selector. As we scale the replicas in a controller with matching labels, Kubernetes will update the endpoint automatically. Now, if we want to create a service for something that is not a pod and therefore has no labels to select, we can easily do this with both a service and endpoint definition. You can see that on the screen right now, these both. First one, here you can see it's Node.js custom service in YAML. And the second one is Node.js custom endpoints. In the preceding example, you will need to replace, the IP address with a real IP address where the new service can point to. In this case, I use the public load balancer IP from the Node.js multi-service we created earlier. So go ahead and create these resources now. You can practice this parallelly while this lecture is going in. You can take a pause and you can create that. So if we now run a get endpoints command, we will see this IP address at port 80 associated with custom service endpoints. Further, if we look at the service detail, we will see the IP listed in endpoints sections. So this basically I am trying to cover. Now we can test out this new service by opening custom service external IP from our browser. Okay, so with this I am taking a pause. I think we have done with the migration. In the next lecture we will proceed up with a few more things like custom addressing and all. Till then I'm taking a pause. So thank you very much.